This is Tim O'Brien from Seattle on November 5th, 2025. And now for today's news. First, there's a critical React Native CLI vulnerability that exposes millions of developer machines. This is a story by Eduard Kovacs from Security Week. This is a particularly big vulnerability. It's rated 9.8 out of 10 on the CVSS scale. That's basically about as bad as it gets. And this is a vulnerability that's going to affect almost everybody that's using React Native. And just in case you don't know, React Native is a way to write mobile applications for iOS and Android using the React framework. The React framework is one of the most popular approaches to creating websites and web applications. So if you're listening to this and you work somewhere that creates a mobile app, it is very likely that you have developers that are affected by this vulnerability. And if they're using tools like React Native or even tools like Expo, they need to look today at what they're running. Metro is a server that React Native uses to bind to external interfaces by default, and it exposes an endpoint called /open-URL. That's the endpoint that's vulnerable to command injection. Any attacker on your network can send a specially crafted HTTP post request and execute an arbitrary command on your development machine. And again, I just want to emphasize, a development machine is often a treasure chest of credentials. Developers will store passwords, GitHub keys, and other things that often allow almost root-level access to other systems. So if you have a developer running a Metro development server that's vulnerable, it would be a good day to upgrade to version 2.0.0 of the React Native CLI-server-API component. And this is a big deal. Again, millions of downloads a week. This is out in the wild, and it rates a 9.8 on a scale of 10. On a personal note, I also develop mobile applications using React Native, and this affects me. The computer I'm recording this on is vulnerable, and after recording, I will patch. For our programming story, we have an interesting one. Joel Severin has a personal GitHub project, and he's taken the time to make the Linux kernel run in WebAssembly. Now, we talked about WebAssembly earlier this week. It's essentially a virtual machine that's in all of your browsers, and you can compile to it. It's a platform-neutral target for things like Rust and C and Haskell. And if you can run Linux kernel on WebAssembly, this means you can run something in your browser that's similar to the Linux kernel. So I want to explain what he had to do. He had to patch quite a bit to get it to work. WebAssembly lacks the memory functionality that you'll have on other platforms. So there's no virtual memory. There's also no process isolation. And that's not a small change. As a result, the Linux kernel must run in something called no MMU mode. And that's every process in the kernel shares one address space. Programs need to be compiled with position-independent code. That's a flag called pick. That brings its own set of challenges and opportunities. There's a lot of constraints, like you can't run fork. But the important part is he made progress. He found workarounds. He's using web workers to simulate multiple CPUs. He doesn't have preemptive multitasking. But it's interesting. If you go to Joel's GitHub repository, you can try it out for yourself. The kernel boots and mounts in an init RAM FS, and it contains something called BusyBox. Your next question might be, well, what is BusyBox? BusyBox is a single, lightweight executable that combines many of the common Unix utilities into a single program. So it's kind of like the Swiss Army knife for embedded Linux. It's designed for environments with very limited resources, such as routers, IoT devices, and the Android operating system. What it does is it provides those core utilities like ls, cat, mv. It provides replacements for many of those standard utilities, and it saves significant disk space and memory. Again, I don't think this is going to be showing up in any products anytime soon, but this is a very interesting exercise that Joel completed. Check out his GitHub repository, and this could start to fundamentally change how we think about operating systems. Imagine running a full Linux system in any WebAssembly runtime. Now, we're a long way from that. There were lots of workarounds that had to be done to get this to work. But we are starting to watch the boundaries between native and web platforms continue to blur. WebAssembly is interesting, and I think it's going to get more interesting as we move forward. And for today's weird bucket story, this one's interesting. There's a genetic mutation that makes people's bones 8 times denser, but they can't swim. I found this on Reddit in the weird subreddit, and it was posted by someone named the Oddity Collector. A bizarre genetic mutation in the LRP5 gene gives a handful of people unbelievably dense, virtually unbreakable bones at a strange cost. According to medical reports, affected individuals have bones up to 8 times denser than normal. People with this condition can literally walk away from car accidents without a single fracture. Their bones are so dense that they show up almost solid white on x-rays. But there's one catch. There's no beach vacations because they can't swim. They just sink like a stone. But this does appear to make them invincible to bone fractures. In one family, 21 members ages 3 to 93 reportedly never suffered a broken bone in their lives. This sounds like some weird secret collection of X-Men. This mutation affects a gene called LRP5, and it was discovered when a man walked away from a severe car accident, completely uninjured. Doctors could not believe the x-rays. This led to a discovery of an entire family in Connecticut with the same condition. Now, pharmaceutical companies are desperately trying to understand this mutation to develop new osteoporosis treatments. But imagine that day-to-day reality. They're basically indestructible on land, but have to stay away from deep water. Evolution really does have a sense of humor sometimes, but carry this forward. If we find out how this happened and can make this mutation happen elsewhere, then maybe we can all be invincible. Let's see what happens. If you want more information about these invincible non-swimmers, you can see the links in the show notes. And there are a couple more news stories this morning because a few things just showed up. The first story is about malware that's using OpenAI's Assistant API to communicate. So Microsoft's security team discovered a novel backdoor, and it's called Sesame Op. And let me explain how it works. It's using OpenAI's Assistant API to establish a command and control channel for communication. And this is not new. If you've ever been owned, or if anyone's ever installed something like this on your system, you'll see these things using internet relay chat, or different ways to find a way to exfiltrate data and to send commands to a distributed network of agents. From what I can see in this story, this is what is being done with the OpenAI Assistance app. If you've ever used the OpenAI app, it has endpoints. It's got an API to create threads for an assistant conversation. And you can post messages, you can read messages. And so don't think about this as this Sesame Op using OpenAI as an LLM or to call anything that's artificially intelligent. This is not that. This is just leveraging that OpenAI API call as a way to communicate between components. Now, here's why this is clever. This is a new API. A lot of companies and organizations don't yet know how to monitor it in a way that's been established. So if you make use of it, it just looks like OpenAI traffic. It's only when you dig into that traffic that you realize something terrible is happening. So while Microsoft hasn't released exploit code for obvious reasons, this attack demonstrates how criminals are turning the very AI tools that we're starting to rely on into weapons that can be used against us. I find this fascinating. I also find it not surprising. Anything that can be used to create a context for communication can and will be, especially after you see vulnerabilities like Shai Hulud being so obvious in how they were trying to move information from the machines that they had attacked. This is smart. Konstantin Rahalski at The Register reports on a major breach at Shift Technology, the French insurance AI startup. This breach wasn't discovered by their security team, but by a customer. The customer noticed that their proprietary models were showing up on a dark web marketplace. A senior engineer had been exfiltrating data for months, including customer datasets, and trained models worth millions. This also proves once again that sometimes the biggest threats come from the inside. The stolen data reportedly included customer insurance datasets and trained machine learning models valued in the millions. This insider was selling the IP on the dark web, causing reputational damage and potential loss of competitive advantage. This incident reinforces that even high-tech companies are vulnerable to insider threats and highlights the importance of monitoring for internal data leaks. Shift Technology has not publicly disclosed full details as law enforcement investigations are ongoing. In other news, YouTube announced a voluntary exit program for its U.S. employees. This marks the latest round of cuts at Google's video platform. According to TechCrunch, The program allows employees to voluntarily leave the company with severance packages, though YouTube hasn't disclosed how many positions they're looking to eliminate. Notably, this comes despite YouTube's strong performance. In Q3 of 2025, YouTube ad revenue jumped 15% year over year to over $10 billion. Alphabet, Google's parent, has been under pressure to improve margins and has conducted several workforce reductions in 2025. The voluntary exit program suggests YouTube is looking to cut headcount, or at least realign talent, while avoiding the optics of direct layoffs, likely as part of its pivot towards AI-driven product lines. The reorg created new teams focused on subscriptions, viewer experience, and creator community products. According to TechCrunch's Kirsten Korosek, Norway's sovereign wealth fund voted against Elon Musk's eye-watering $1 trillion compensation package at Tesla. The fund, NBIM, owns about 1.14% of Tesla, which is valued at $11.7 billion. It cited concerns over the size of the award, the dilution, and the lack of mitigation of key personnel risk in Musk's compensation plan. Their vote adds to growing shareholder pushback. Influential proxy advisors ISS and Glass Lewis also recommend voting no on what would be the largest executive pay deal in corporate history. Musk argues the package, a performance-based stock grant, is about securing his commitment to Tesla's future, not just the money, and even hinted he might quit as CEO if it's not approved. Tesla's shareholder meeting is approaching, and the corporate governance spotlight is on whether investors will rein in Musk's rewards. Norway's public stance, surprising for a typically hands-off investor, is seen as a stand for prudent governance. Even if this proposal passes, this symbolic rebuke by a major fund and others raises questions about board oversight and the concentration of power at Tesla. For more information or links, see the show notes. And that's the technology news for November 5th, 2025. If you're interested in any of these stories, please see those show notes. And for today's feature, we're going to talk about Git. And specifically, we're going to talk about Git's history and any discontents that might dislike it in its current moment of success. And a quick note to listeners. It's a heads up for non-technical audiences. Before we dive in, just a real quick note. Not every episode of this podcast is going to be super technical. Just 2 days ago, I did a story on the Chelyabinsk meteor, and that was a space rock exploding over Russia. I think anyone would enjoy listening to that without a coding background. Yesterday's episode was also similarly general audience. It was about aviation history, autopilot, how we're starting to use AI for air traffic control. Again, you could listen to those without knowing how to program. Today, I'm going to go into full geek mode, and I'm going to talk about Git. Git's a version control system for tracking code, and it's a tool that's mainly used by software developers. It helps you collaborate and manage source code. So one piece of feedback I've heard is that I should warn listeners when I'm about to get highly technical. Consider this that warning. If you're not a programmer, I won't be offended if you tune out, but I actually think it might still be interesting to hear how this tool influences the technology that you use every day. But I'm not going to stop and explain every single thing that I mentioned, and you already saw some of that in today's news coverage. There were so many acronyms it would have taken another hour for me to fully explain everything. So to recap, today's topic is Git, what it is, why it's important, and some of its pain points. I might not slow down to explain every single technical term like I usually do. I'll be comparing Git to some other systems like a system called Mercurial, and I'll be talking about nerdy things like monorepos. If you're not up for that ride, no worries, you've been warned. But if you stay, I promise to try to keep it high level enough that you'll get the gist. And that wasn't a pun on GitHub gists. So fair warning delivered. I'm putting my propeller hat on now, and we're going to be talking about geek stuff. I want to begin with a quick introduction. Why I think Git changed everything. I'm personally convinced that Git is one of the most important inventions of this century. I think LLMs are also probably the most important. Unless we invent a transporter beam in the next 75 years, it's probably going to be generative AI. But Git has pushed a lot of change in how we create software. And in some senses, it might have actually led to the fundamental conditions that made innovation in AI possible. Now that sounds like hyperbole, but let me make the case. Git fundamentally changed the way software is developed and how open source collaboration works. To appreciate that, you have to go back to the early 2000s. Back then, most open source projects used centralized version control systems like CVS or Subversion. Those systems had a single master repository and a server, and only a few people, quote, the committers, had the keys to directly change that code. In that world, if you wanted to contribute to a project, you often had to ask for permission or submit patches. You had to befriend people and get to know them. There was a vote. Forking, which means creating your own copy of the repository to modify it independently, that was often seen as a weird, hostile move. Like, what are you doing? Why are you forking this project? Are you going to try to replace us? It was like saying, I'm taking my ball and I'm going home. I've got better ideas. So the culture around open source had become oddly hierarchical despite its egalitarian roots. And these tools reinforce that. Subversion, which I used heavily in those days, and its predecessor CVS, were centralized by design. And that was one canonical codebase controlled by an inner circle. Then, in 2006, Linus Torvalds created Git, and it quietly reshaped the landscape. Git was distributed and deeply decentralized. And that meant that every developer could have a full clone of the repository on their own machine, with all the history. This sounds technical, but the upshot was huge. Git made branching and forking not only easy, but normal. Suddenly, making your own copy of a project to experiment with wasn't an act of defiance. It wasn't hostile. It was encouraged and routine. That's what you had to do every day. If you had an idea or a fix, you didn't need to lobby for commit access. You could fork the project instantly, build your changes in isolation, and show people, here's my fork. If you want my changes, go ahead and consume them. If you really wanted to, you could then propose a pull request. And a pull request in Git is when you take your fork and you make a request to merge your changes into another branch or the source. So that change in workflow flipped the power dynamics of open source. Experimentation became cheap and free-flowing, rather than something that needed approval from a series of gatekeepers. And I wrote a blog post and I recorded a podcast episode about that history. I called the 2010s, quote, the Great Decentralization. And I called it that because of Git. In the span of that decade, Git unseated Subversion as the dominant tool, and a new platform called GitHub turned version control into a social network for code. And you don't have to believe me, just look at the numbers. SourceForge, the big open source code host of that Subversion era, had about 240,000 projects around 2010. A decade later, GitHub had 190 million repositories. And as of early 2023, GitHub reported over 420 million repos. They're on pace to hit 1 billion, and that's an explosion of activity. And many of those repositories are going to be hobby projects or forks, but that's the point. Git made it easy to create new projects and fork existing ones, and the experimentation, the communication involved in open source skyrocketed. So Git didn't just speed up how we commit code, it changed the culture of collaboration. Again, forking a code base became a gesture of interest and innovation rather than an insult, and it removed friction. I'd argue that open source as we know it today, this massively collaborative, fast-evolving ecosystem, was enabled in large part by Git. And that's why I rank it as one of the most important inventions of this century. It took those power structures, those high places, and it helped to cast them down. On a personal note, I will admit that I was not an early Git convert. Prior to Git's rise, I was a huge proponent of Subversion. Subversion is basically designed to be a better CVS. It fixed a lot of CVS's quirks, and for a while in the mid-2000s, Subversion was the cool new version control system. And at the time I lived in Chicago, and Chicago needs all the support we can give it right now, so I want to give a shout out to the Chicago-based developers who made it happen. Benjamin Collins Sussman was one of the founding developers of Subversion, along with Carl Fogel, Jim Blandy at CollabNet, and Brian Fitzpatrick joined as a core developer in 2000. Collins, Sussman, and Fitzpatrick went on to co-found Google's Chicago engineering office and literally wrote the book on Subversion. Version Control with Subversion from Riley is something I still have on my bookshelf. Also, quick aside, Brian and Ben actually recorded a couple of really helpful videos about how to manage teams and how to avoid difficult people. They wrote a book about that as well. I would recommend that you go buy it. It's a timeless classic. So these are the individuals that bridged us from the seemingly archaic world of CVS to the more modern era of version control. I used Subversion for everything. I was happy with it. Sometime around 2010, however, I noticed the ground was shifting under my feet. Practically overnight, it felt like the development world moved to Git. I was doing work with a startup that happened to be associated with the Apache Software Foundation. Most Apache projects were using Subversion, but this one was starting to move to Git. And I don't remember a real heated debate or even a conscious discussion about it. People just started to use Git because it started to make more sense. It's what everyone else was doing. And I recall trying Git out and encountering its steep learning curve and quirky commands. I was on a project with someone named Matthew McCullough, who later went on to work at GitHub, and he wrote all the books about Git. But I will say, if you've ever used Git for the first time, it doesn't make any sense. It's a complex tool, but once you start using it, you get used to it. And it really starts to prove itself when you have multiple people making changes at the same time, and you have to do a merge. In CVS, that'll literally cause a nervous breakdown. In Git, it was just normal. I think part of it was a new generation of developers started to grow up with Git and just assume that that's how you collaborate. And I think part of it was seasoned developers were gradually starting to see the advantages: offline work, quick branching, easier merges, and the ability to experiment freely without messing up the main repo. So by early 2010s, Git had effectively unseated Subversion and other competitors. I can't recall a single meeting or memo in 2010 that declared, we're all going to use Git now, everybody stop talking about alternatives. It just happened. And that sort of ubiquitous adoption, in retrospect, is astonishing. It speaks to how well Git solved the problems of the time, and its decentralized open source changed the psychology of contribution. Now, I'm heaping praise on Git, but today's episode is actually about Git's discontents, the cracks or limitations that exist in this otherwise beloved tool. And I'm doing this because we're about to approach its 20th birthday. It was born in 2005, 2006, so its 20-year mark is coming up fast. I expect we'll see a lot of celebrations about how awesome Git is. Maybe there'll be a parade somewhere, and I'll celebrate it too. But the contrarian in me also wanted to ask, is there any dissenting opinion? Are there use cases where Git isn't working well? And are we all so comfortable with Git now that we ignore its flaws or alternatives? And I bring this up because, remember, in the early 2000s, I was using Subversion and was perfectly happy. It was only when I started looking at my own experience and looking at what was out there that I started to change my mind. So don't take this as me writing a bad thing about Git. I use Git. I love it. But in the spirit of healthy skepticism, I've dug into a few areas where developers have found Git less than ideal. And I'm going to talk about 3 topics. First, Git struggles with massive code bases, the monorepo problem. 2, the fact that Git's success has made GitHub a sort of single point of failure for open source. And 3, what alternatives to Git are out there in 2025 and whether any of them have a shot. And I'm going to have a check-in on Subversion as well. I want to be clear up front, I am not personally planning on abandoning Git after writing this podcast. I use it every day and it's deeply ingrained in how I work. Think of this as a thought exercise, poking at the edges of Git's reign to see where things could get better, or at least where caution is warranted. Okay, so let's get started with our first topic, Git versus massive monorepos, when repositories get too big. One known issue is that even Git's biggest fans will acknowledge that Git can choke on really large repositories, specifically the type we call a monorepo. And let's define that term. A monorepo, short for monolithic repository, is a single version control repository that houses the code for many projects or for an entire company. For example, Google famously has or had one giant repository for most of its code. And so do some other tech giants. Facebook is one of these companies as well. The idea is that keeping everything together can simplify dependency management and code sharing. But it also creates a monster repository. We're talking millions of files, dozens of gigabytes of history. And this is the sort of issue that comes into play when you're working at a very large technology organization, or even a small one, if your application is modular enough. And here's what it looks like. Let's say you have, 3,000 people working on a website. You could 100% split it up into separate components. You could have one component that's in one version and another component that's on another version. Maybe you have a separate release process for components. You're tracking dependencies between them. Where it gets complicated is if you have multiple teams working on different versions of those components, and then you have to worry about merging some of the shared differences. And if you have, 100 different repositories for 100 different components, it can become a real challenge to figure out how to merge those to create one common release. If you put it into a monorepo, Sometimes it's easier to deal with simultaneous editing of the same component. And I probably just simplified it dramatically, but in my experience, this is a problem that doesn't have a direct answer. In fact, I tend to err on the side of not using monorepos, or if you do want to combine repositories, make sure that you're guiding it by the organization or the release schedule. Again, I could talk about monorepos, pro and con, for about a day each, but know that it is a complicated area of debate. So Git wasn't really designed with that scale in mind. Remember, Git came out of the Linux kernel community. And while the Linux codebase itself can be large, it's nowhere near the size of, say, all of the code that Google is creating in a given year, or Facebook. For normal-sized projects, Git is very fast and efficient, but as you start to add millions of files, some of Git's internal operations slow to a crawl. One notorious example is Facebook. In the early 2010s, Facebook's source code had grown many times larger than even the Linux kernel. The kernel was 17 million lines and 44,000 files for comparison. Facebook initially was using Git like everyone else, but around 2012, their engineers started to notice that basic Git commands were getting sluggish. Not just a little slow, but painfully slow. They didn't experiment. They simulated with what their repository would look like in a few years, and they timed some of the Git operations. The results were alarming. In that dummy mega repo, doing something like a Git status or a Git commit might take on the order of tens of minutes to complete. One recollection from an engineer was that they projected certain commands might take 45 minutes or more as the code base grew. And that's just not a realistic or productive day. Imagine writing some code and then wanting to do a commit, and then you can go get a cup of coffee, or maybe two, sit down and read a couple hundred pages in a book. That's just not the way that programmers want to work. A programmer wants to develop code, make a commit to source control, and have that take maybe a couple seconds max. So Facebook's team reached out to the Git open source maintainers and basically said, hey, we love Git. It's not handling our repository size. Can we work together to make Git scale better? And now here's where the story gets interesting. The response from the Git maintainers was basically, your repository is huge. You should split it up into smaller pieces. And that's actually where the whole monorepo debate starts to come into play. They actually advised Facebook to break the monorepo into multiple repositories rather than trying to make Git handle one giant one. In their defense, at that time, the common wisdom was that monorepos might be impractical, and that Git's design assumed that repositories would be reasonably sized. One maintainer noted, there's only so much you can do about statting 1.3 million files, meaning that if you have to scan a million files, it's just going to be slow. In 2012, the Git community didn't see it as their job to support use cases as extreme as Facebook's. But as supporters of monorepos usually do, they really believed in their approach. So just split it up was a non-starter. Instead, they evaluated alternatives. There weren't a ton of distributed version control systems to choose from. Basically, the main Git competitor was Mercurial. Plus, there were some older or more proprietary systems like Perforce. After some internal testing, Facebook's engineers made a bold move. They decided to migrate off of Git and onto Mercurial around 2013. Mercurial is another distributed version control system that was coincidentally released around the same time as Git. It's written largely in Python and was known for a cleaner codebase and extensibility. The Mercurial maintainers were reportedly more welcoming to collaboration. Facebook's team literally went to a Mercurial developers meetup and found them willing to accept patches to improve performance. Over the following years, Facebook poured effort into making Mercurial scale. They even built custom extensions and a new back-end server called Mononoke, designed to serve their giant repository efficiently. So Facebook could keep their monorepo without grinding developers' machines to a halt. Mercurial, with those enhancements, handled that big code base better than Git did at the time. And in hindsight, this was a bit of a wake-up call to the Git community. Being out-innovated by Mercurial in the large repo department was not something that the Git folks liked to hear. A couple of years later, after seeing what Facebook achieved with Mercurial, some Git contributors changed their tune and started working on large repository improvements. Fast forward to today, Git has gotten better at handling large repositories. There are features like sparse checkout, shallow clone, and partial clone that let you avoid pulling down the entire repository or every directory if you don't need them. Companies like Microsoft have also contributed to Git's scalability. In fact, Microsoft moved the entire Windows code base, which isn't an enormous project. I think it's on the order of 3.5 million files for a single checkout. They moved that to Git a few years ago, and to make that feasible, they developed a Git virtual file system, a GVFS. And let me put that in perspective. When they first tried the vanilla Git, cloning the repository took 12 hours. And that's untenable. Checking out a branch could take 3 hours. And even running a simple Git status took about 10 minutes. Those numbers are ridiculous. Imagine waiting half your workday for a code checkout. But with GVFS, which basically makes your computer pretend all the files are there and it downloads them on demand, and some custom Git optimizations, Microsoft slashed those times dramatically. After their improvements, that 12-hour clone was cut down to a few minutes, and a 3-hour checkout became maybe 30 seconds. In short, they bent Git to handle a monorepo that big, proving it's possible with enough engineering effort. It's also worth noting that Google, which is possibly the largest monorepo on the planet, never used Git for it. They built their own system, a bespoke version control called Piper, and a wrapper called CITC, C-I-T-C. So we don't really have a story about Git from Google, other than the fact that they built their own alternative. The takeaway here is that Git's Achilles heel can be extremely large repositories. For 99% of software teams, this is not an issue. Their repos are nowhere near that size. But for the elite few with those mono repos that are the entire scale of a Facebook or a Windows code, out-of-the-box Git can struggle. In fact, it's just unrealistic. So you either switch to something like Mercurial, like Facebook did, or you modify Git itself, as Microsoft did, or you abandon the monorepo concept altogether. I do find it interesting that earlier in Git's lifetime, when Facebook had problems with it, the Git community wasn't like, oh yeah, sure, we'll fix it. They were like, just don't do that. And I think that's interesting, but it's also the way it's supposed to work. Remember, open source projects are not there to do everything you need them to do. And I sometimes wish people using open source would realize that. Facebook came to Git and said, can you help us? They said, just don't do that. So they found an alternative. Microsoft maybe had a little bit more interest in Git because they owned GitHub. They found a way to make it work. But I think this is just an example of two different approaches, two different paths. So for most of us, the lesson is more curiosity than direct impact. Not a lot of us are working at organizations that have repositories this big. And it's interesting that this tool that is so ubiquitous has scaling limits. I've spoken to somebody about this just in the last week. It's a reminder that different tools shine in different scenarios. Mercurial, for instance, proved better for a time in this extreme scenario. In fact, Facebook's developers noted that Mercurial's architecture was cleaner and a bit more hackable for their needs. And just to reiterate, if you have a monorepo and it's very large, take a look at the links in the show notes and you can see some of the analysis, some of the history here. It's up to you whether or not you want to use a monorepo or not, but if you do have a repository that's the size of the planet and you don't make any modifications to Git out of the box, it's going to start to sweat. So let's shift to another concern that has less to do with the software itself and more to do with the ecosystem, GitHub's dominance. It's impossible to talk about Git's success without also talking about GitHub. GitHub launched in 2008 and quickly became the go-to platform for hosting Git repositories. Today, I would wager that the vast majority of software developers use GitHub, either directly or indirectly. I'll put my hand up. Nearly everything I work on is hosted on GitHub, whether it's an open source library or the blog posts I might write in Markdown or the scripts for this podcast. Everything that I do is on GitHub. It's reached a point where Git, the tool, and GitHub, the service, are intertwined. And while I do know that there's a difference, if I'm using Git, I'm most likely committing to a GitHub repository. So again, Git and GitHub are very intertwined as a concept. And there is a ton of good that came from this. GitHub made Git more social. It provided a friendlier web interface to browse code, to track issues, and to merge contributions with pull requests. It lowered the barrier for newcomers to contribute to projects. I remember 2 decades ago, if someone wanted to submit a patch to an open source project, you had to send an email, and the email had to be properly formatted. And there were constantly fights about if the formatting was right or wrong. It was just a mess. With GitHub, you could literally just click fork and off you go. It also created a discovery hub. These days, if your open source project or your startup is not on GitHub, a lot of people might not find it. Honestly, GitHub's ubiquity is part of what helped Git crush Mercurial and others. Network effects are real. People want to be where other developers are. And in that sense, GitHub is like the Facebook of coding. However, this raises a bit of a paradox. Git, the tool, is decentralized by design. No single server is necessary. You can collaborate peer-to-peer if you want. In theory, every developer's laptop is a full backup of the repository. Yet in practice, we've centralized around GitHub as one huge hub for code. There's an insightful blog post by an open source developer named Ariadne Conil, and he puts it bluntly. GitHub is now effectively a single point of failure for the commons, since the overwhelming majority of software is developed there. And think about that. If GitHub were to have a prolonged outage, or say a policy change that made a bunch of projects leave, it would wreak havoc. In 2018, when Microsoft acquired GitHub, there was a brief flurry of should we all leave GitHub discussions. Some people did migrate to GitLab, but most stayed. And the fact is, GitHub has become a critical piece of infrastructure for software development. But again, I'll reiterate, it is an irony that we traded that old centralized model for a new kind of centralization. And to GitHub's credit, they've been good custodians overall. We haven't seen anything dystopian from them, but the potential for issues is there. For example, there have been incidents where GitHub, to comply with US law, restricted access to certain countries or users, like temporarily restricting Iranian or Crimean developers due to sanctions. And for the record, I'm also subject to United States law, so I would have to do the same if I ran that service. But it doesn't isolate them from criticism from users outside of the US, that there is some dependency on this single resource. It's also true that as an industry, we've started to become more dependent on GitHub for things like continuous integration via GitHub Actions, pages via GitHub Pages, package repositories. It's a fabulous one-stop shop, but as Ariadne's post notes, it also means that we've largely traded our autonomy for convenience. And I also just want to point out an analogy. Think about Twitter. Jack Dorsey founded Twitter, and it was this powerful force of nature. I mean, it developed over the last decade and a half. And it turned into a thing that was shaping the news, shaping politics, shaping elections. And when ownership changed to X, a lot of people left because they weren't comfortable with some of the policies of the new owner. Now, I'm not going to comment on those policies or whether or not you should have stayed on Twitter or left, but I do want to point out that GitHub is in the same position. It's something that we all depend on. And if it changes hands, if it changes policy, that could have an impact on open source. So this is Ariadne's point. So I have to catch myself here because I'm absolutely part of this trend. I love the convenience. Setting up my own Git server on my own domain or using something like email patches in a mailing list is just not what I want to do. I recently read a post on Medium where someone was saying, you don't need GitHub, you can just use an SSH server, and here's how you do it, and gave all the instructions. It is very straightforward. You actually do not need to use GitHub. But I rely on the fact that GitHub is there. It's convenient. It takes care of security, authentication. It takes care of hooking it up to GitHub Actions. That's nothing I want to spend time on. But maybe the most important thing is that network effect. If I host my own GitHub repositories on VMs running SSH only, it's basically invisible. If I put it on GitHub, I instantly tap into a huge audience of developers. And it's trivially easy for someone to contribute, to fork and change, and then submit a pull request. And that's the path of least resistance for collaboration. So I'm going to favor convenience over freedom, but in economic terms, it's the coordination equilibrium that has landed on GitHub. We all go there because we all go there. Is that a problem? It could be. It means we're putting a lot of trust in one company, Microsoft ultimately, to be a benevolent steward. And to be fair, they have done great. But the history of tech shows that centralized platforms can become choke points. A bit of vigilance is wise. Some projects have contingency plans. For example, the Linux kernel famously does not use GitHub. They still do patches over email and maintain their own Git servers. Likewise, some communities, like maybe certain blockchain projects or Monero crypto folks, they ensure that there are myriads of repos in case GitHub were to vanish or ban them. There's also this burgeoning movement to re-decentralize code hosting. One approach is federation. Projects like ForgeFed aim to let different code forges, instances of GitLab or Gitea, for example, interconnect so that you could have a decentralized social network of code instead of one central site. Another approach was pure peer-to-peer, something called Radicle, R-A-D-I-C-L-E, tried to create a peer-to-peer network for Git repositories. It was using crypto and blockchain tech, though some have criticized it as over-engineered. None of these have caught on at scale. It might just be that the convenience of this central platform is too high, and the pain points haven't been painful enough to spark a mass exodus. From my perspective, I am aware of that irony. This is a distributed, decentralized tool, and it's led to the most centralized source control service one could imagine. I occasionally remind myself not to put absolutely everything only on GitHub. For example, I keep local backups of important repos, but I've experimented with mirroring some of them to GitLab or other places. But realistically, if GitHub were to have a problem tomorrow, almost the entire internet would freeze. It would be not dissimilar to what happened to Amazon Web Services 2 weeks ago on the 20th of October, 2025. And it's that dependence that I think we need to start thinking about. A few years ago, GitHub had an hours-long outage. I recall it was due to some database issue. And developers around the world basically twiddled their thumbs, waiting for it to come back, because they could not pull down dependencies or push code. To sum it up, GitHub is a phenomenal tool and a community hub. I rely on it myself daily. But it's a single point of dependency for a lot of us. And this is one of Git's subtle discontents, not with Git itself, but with how the ecosystem consolidated. It's like we got rid of the old king, central VCS servers, but we crowned a new one, GitHub. And for now, this new king is benevolent and extremely useful, but it's something I think we need to keep an eye on. In the long run, maybe the pendulum will swing back towards more distributed models as technology like federation matures. For now, though, practically speaking, if it's not on GitHub, it might as well not exist. And that's not being fair to GitLab. GitLab has some great people and some great technology. So maybe that's the next step. If you resonate with this section, maybe I would offer, don't stop using GitHub. Take a look at GitLab. Try to have at least 2 options in an area as critical as this. All right, for the final part of this discussion, I want to look at alternatives to Git. We've hinted at a couple, Subversion and Mercurial, but let's talk about what else is out there in 2025 and whether any of these tools address Git's shortcomings or offer a compelling reason to switch. All right, for our last section, it's called Git Alternatives. Is there anything better on the horizon? Despite Git's dominance, it's not the only version control system in the universe. There are older systems that predate Git and a handful of newer ones that try to innovate beyond Git. Part of why I explored this topic is sheer curiosity. Are there people out there dissatisfied enough with Git to be using something else? Or are there any serious projects that stuck with other tools? Let's run through some of the alternatives and see where they stand. First is an old favorite, Apache Subversion, SVN. This was the king of open source version control before Git. Subversion came out in 2000 as an open source replacement for CVS. It's centralized, meaning there's one repo on a server and everyone commits to it. I have a lot of nostalgia for SVN. It was simple to understand, trunk, branches, tags as directories. It worked fine for many projects. In 2023 and 2024, Subversion is largely legacy. The vast majority of active development projects have migrated away from Subversion over to Git. And even those who were staunch SVN users, for example, some big open source foundations, eventually caved. For instance, the core development of GCC, the GNU compiler collection, was on Subversion until 2019. Then they moved to Git. That said, Subversion is not dead. It's an Apache project and it's still maintained with periodic updates. In fact, the latest release as of the end of 2024 was Subversion 1.14.5, and it was released on December 8th, 2024. These updates tend to be bug fixes and security patches, not big new features. Subversion is mature and in maintenance mode, but it's stable. There are still companies and older projects that use it internally. If you have workflows that rely on centralization or you want to easily manage large binary assets without Git's complexity, Subversion can do the job. The trend, however, is that new projects almost never choose Subversion. Personally, I haven't used it in about a decade, but I remember it fondly. Some of the first open source projects that I were involved in started at CVS and then migrated over to Subversion, and it was a breath of fresh air. For the next alternative, it's Mercurial. We've already talked about Mercurial in the context of Facebook. Mercurial was Git's direct competitor in the late 2000s. Now, Google used to have a place to host code as well. It was called Google Code. And they only supported Subversion at first, but then they added Mercurial support. They never added Git support until much later, by which time GitHub had already won. Mercurial has a lot of similar capabilities to Git. It's distributed, you can commit offline, you can branch and merge, but it has a different philosophy. Mercurial aimed to be more user-friendly and had a consistent command line interface. Many found that Mercurial was easier to learn. The Python community was a big fan of Mercurial. The language's source code was managed with Mercurial for many years, but they eventually transitioned to Git and GitHub around 2017. As of 2025, Mercurial is still around and is actively developed by a small but dedicated community. They recently released Mercurial 7.0 in 2025, and it shows that they're keeping it up to date. Some of the high-profile projects that use Mercurial have migrated away. For example, Mozilla was historically a Mercurial shop for Firefox code, but even Mozilla announced a move to Git and GitHub in the last couple of years. One reason Mercurial lost ground is that major hosting services dropped support. Atlassian's Bitbucket, which once hosted loads of Mercurial repos, shut that door in 2020, essentially forcing those users to convert to Git or find a new platform. That was the nail in the coffin for widespread Mercurial usage. Still, it's interesting. Technically, it's excellent. Some say it handles certain merges much more gracefully than Git and has a more coherent design. Facebook proved that you can scale it up to handle large monorepos, but Microsoft also solved that problem with the Git virtual file system. Mercurial has become a niche tool. I'd venture most new developers today haven't heard of it. It survives in pockets, and the folks who love it really love it. So if you ever find Git to be utterly baffling, if the documentation is destroying your mind because it's complex, go take a look at Mercurial, and I'm sure you can find somebody you know who's used it. Let's talk about some of the legacy source control systems out there. CVS is one of them. It's basically obsolete. It's the predecessor to Subversion. No one should use it. Perforce is a commercial version control system that was popular in certain industries, especially game development and large enterprises before Git. It's centralized and extremely fast for certain operations, and it handles huge binary blobs as well. Some game studios still use Perforce because of those strengths with large assets, but it's proprietary and somewhat expensive. Git has largely eaten its lunch for general software, though Perforce still has a niche. The company pivoted more into offering Git tools as well. There's also Team Foundation Version Control, TFVC from Microsoft, and this was part of TFS and Azure DevOps. Even Microsoft realized that Git is what developers want, so they now primarily offer Git hosting. They also own GitHub. What about new wave or experimental version control systems? What's next? Is there anything next? There are a few out there, though none have really hit prime time. An interesting project is named Fossil, Fossil. This tool was created by the same person who created SQLite, D. Richard Hipp. Fossil is a distributed VCS like Git, but it's an all-in-one solution. The repository is a single file, and it includes an integrated web interface, a wiki, and a bug tracker. SQLite's source code is managed in Fossil, and Fossil has a small following. It's a very self-contained and elegant solution, but it's not going to unseat Git. One other is Pijul, P-I-J-U-L, and this came out of academic research on patch theory. Pijul's promise is to make merging and tracking changes more mathematically robust. In theory, the goal is easier merging of long diverged branches. Pijul hit version 1.0 in 2023 and is written in Rust. It's pretty cool conceptually. Instead of tracking snapshots like Git, it tracks patches, but it's definitely in the experimental realm for now. And then there's the whole idea of using blockchain or P2P networks for code. I mentioned Radical earlier, which uses a peer-to-peer network to share Git repos without a central server. It's a novel idea, though the uptake is minimal, and it requires a separate client. Others see Radical as something that might be attached to some distracting cryptocurrency projects. That makes a few people weary. What about Git itself? How is Git changing? One could argue that the biggest competitor to Git is now really just different interfaces around Git. For example, there are high-level tools that make Git easier without changing the underlying storage, Tools like GitHub Desktop or Tower or SourceTree, these are GUIs for Git. They help lower the learning curve, but ultimately, they still use Git under the hood. There's also Darks, an older distributed system predating Git that had a very cool approach to patches, but struggled with performance. In summary, if you look at alternatives, there's really not a lot of alternatives that aren't just niche. And it's important to understand that Git really has become one of the only players in this game. So if anyone's asking the question, who's resisting Git's empire? The short answer is not anybody in the mainstream. GitHub's dominance has kind of cemented Git as the lingua franca of open source. If you tell a new developer to learn version control, you tell them to learn Git, and there's really no question about that in 2025. Alternatives like Mercurial or Subversion are mainly of historical interest and for special use cases, like a specific legacy project or personal preference in a small team. I have no doubt that someone's going to be listening to this podcast and take offense to that. But from what I can see, the statistics bear out this truth. Git's the winner. I was curious about Subversion's recent activity, and as noted, it's on version 1.14 and still getting security patches. That tells me that there are enough users to warrant keeping it up to date, but it's definitely in maintenance mode, not innovation mode. Mercurial is in a slightly more innovative space. They actually added some interesting features like chain set evolution, which Git doesn't have an exact analog of. But again, without major mindshare, it's hard to see Mercurial mounting a comeback. Maybe the next replacement for Git won't be a new version control system at all, but rather a new approach. Some way of collaborating on code that doesn't use diffs and merges in the same way. I've heard some people speculate about AI-assisted version control or fully hosted conflict-free CRDT-based collaboration, like how Google Docs lets multiple people type at once. I can't imagine coding that way, because mostly I don't want to have another coder stepping over the things I'm changing. That's why I use version control. That's also science fiction for now, and even if that emerges, I probably won't like it. But again, for the record, I didn't like Git when it came out, but ultimately it won. I'll also add my own criticism of Git, because it's something that I experience quite a bit. And I want to make sure before I say this, just to let you know, this is more a criticism of my own impatience than of Git or GitHub. But if you've ever had to take somebody who is not a programmer and not particularly technical and show them how to use GitHub, just to edit a text file or to edit a simple script, it's challenging. I still have yet to find a tool that I can send to somebody who isn't technical, is not a programmer, and say, hey, here's this tool, use it, here's what a commit is, here's what happens when you do a push or a pull. Conceptually, there's a lot of overhead. And I know a lot of people are going to respond and say, well, that's why you use Google Docs. All of it's versioned. But there's still something missing. I think as more and more people start to experience programming because of generative AI, notice I didn't say vibe coding. Again, I hate that term. But as more people are exposed to programming, I think it's going to be more important for us to create a tool that's a little more inviting than Git, or to build tools on top of Git that make it easier to use. I just don't see it. And that could just be the complexity of training a non-programmer to think about the fact that they might write something and want to roll back to a previous version, or explaining what a diff is. It's a challenge. So I don't see any way for non-programmers to use Git without it being a real stretch. But I also don't see a viable heir to Git on the horizon. Instead, what I see is Git itself adapting. New features, better UIs, integration into new IDEs, maybe some new features that facilitate AI contributions. I think the discontent around alternatives is mostly nostalgic. I will predict that a couple of Mercurial people will hear this podcast and respond vociferously. But what I want to tell you is that I think Git doesn't really have a viable alternative, other than, say, Mercurial, for very focused requirements. So the conclusion here is celebrating Gits, warts and all. As we come to the end of this deep dive, let me reiterate, I am not secretly planning to dump Git. I'm not moving off of GitHub. This exploration was motivated by curiosity and a bit of devil's advocacy. Git has been almost universally praised and adopted, so I wondered, what are the pain points? Is there anybody pushing back? We found a few. It doesn't love huge monorepos. It has indirectly led to a new centralization, and we should be mindful of that. But there really are no alternatives. None have really solved the problem that Git solved and gained significant traction. Depending on your definition of started, Git has already turned 20. and there are blogs and tweets honoring how far we've come in those 2 decades, I'll likely join in because I actually think Git is great. Again, I said it's one of the most important things that has happened to date this century. The minor gripes we discussed today don't change that big picture, but sometimes the contrarian me just likes to poke at the success story and see if there's any overlooked gotcha. On a personal note, one of the enduring discontents I have with Git is how it still manages to confuse me sometimes. Even after years of daily use, I'll confess something. I know the author of one of the most popular Git books out there, Matthew McCullough. He literally wrote a book on Git, and I have it. It's right next to me. Yet, despite owning that book, I've never fully read it. I understand how Git works. I can do a rebase. But there are times that I have to do things with Git, and I'm still looking it up. I'm almost in the same place with Git that I am with regular expressions. And maybe this is a weakness I shouldn't be admitting on my podcast, but I always have to Google regular expressions. And if it's not a basic Git command, I'm always having to Google, how do I do that again? And there are things you can do in Git that you probably shouldn't do. Forcing a push, rewriting history. If there's a weird merge conflict, I'm going to take a break and have a small panic attack before I look up what to do next. And I've heard many seasoned developers echo the same. Git is powerful, but man, it can be mystifying. And there's also a website called Oh Shit, Git. And because I said that title, I'm going to have to mark this episode as explicit. And that's basically a collection of uh-oh scenarios and how to get out of them. So if you sometimes feel like Git is a bit of a dark art, you're not alone. I find that kind of charming in a way. I like tools that sometimes confuse me. And Git deserves the accolades for what it enabled in software development. Its discontents, the issues, the questions we talked about, those are real but relatively minor. As with any dominant technology, it's healthy to periodically assess the limits and watch for changes. And who knows, maybe 10 years from now, we'll all be using some AI-driven version control that makes Git look primitive and does all the thinking for us. Or maybe we'll still be using Git like we have for the last 20 years. So here's to Git at 20, a little rough around the edges, occasionally perplexing, but transformative. And as I push this podcast script to GitHub, I'm going to check to see if I'm on the right branch before I merge that commit. Because if this goes to the wrong branch, I'm going to have to look up exactly what to do next.